We're going to be talking about the innovations that are going on within public key infrastructure that are trying to match what's going on in the IT security landscape. There's all kinds of new computing architectures that are being utilized today. Back when I was working in the mid-1990s, even up until now, the rate of change has never been more than what we're seeing today. And we're going to go through some of the transformational use cases that people like CIOs and CISOs are having to deal with. I think people are starting to lose visibility. It's getting tougher to have good governance. This is something that was paramount in PKI for decades and is now becoming more and more difficult. So the PKI industry has had to step up to try to not just innovate, but to really truly solve these problems in a way that keeps you secure, keeps adoption levels high, and ultimately fulfills those goals of governance, uptime, all those things that are important to you as a modern enterprise. How is that going to be done? The theme that you're going to be seeing over and over again within my deck as well as Lindsay's is continuous innovation, especially in the areas of automation. So in other words, what you're going to see is just enormous amounts of complexity brought into the new modern use cases for IT, and especially in security. And it's going to be automation at the center of trying to solve some of those challenges. But bottom line is that identity and identity-based security through PKI remains absolutely essential. It's been around for a long time. It's pervasive in most of what we do, and that's not going to change. Being able to innovate to keep pace with these new use cases is important. I think that whenever we look at some of these newer use cases, PKI is typically at the center of it. Even though it's not talked about oftentimes as part of the sizzle of the new technologies, quite often there's PKI at the center of it and behind it. So let's talk about how PKI has evolved to fit some of these new use cases. So most of what anybody in this audience might have seen in their past career so far in terms of public key infrastructure has been around SSL and TLS. It's one of the most common use cases for PKI. And what you'll typically see with SSL and TLS is the changes that have gone on have mostly been around the web server. What used to be just one Apache or Nginx server or IIS server has now turned in for an enterprise into dozens or hundreds. I've seen up to thousands. And then if you add load balancers into that equation and every other way that we serve content through CDNs, the automation within SSL use cases is becoming increasingly important, to especially to maintain uptime. User authentication, something we've seen in the past decade and a half, big use case. Authenticating into the cloud through SSH, signing documents, and SMIME. These things have been around a long time. These are the traditional PKI use cases that most of you have seen, either in the public or private trust world. But the transformational use cases that we're going to be highlighting today really are around mobile devices, DevOps, interestingly. We'll get into that detail quite a bit. And then not just SMIME, but something that we like to call authenticated email, which is a fully automated management system for those SMIME keys and certificates. So additionally, another challenge that I've talked with a lot of customers is multi-cloud. How do you utilize a trusted third-party CA in order to be able to span trust across multiple public clouds? And then, of course, a really difficult problem, which is IoT. And we're going to talk about technologies that we have innovated to help solve those problems as well. So what are the risk factors, right? We talked about these transformational use cases, but ultimately, what are these risk factors that we're talking about? Well, with multi-cloud as an example, it's all about the technical silos. The problems that you're having, the pain points that you're having, have a lot to do with the fact that each public cloud is trying to lock you in with their key management technology. If you want to move compute loads from one cloud to the next, and you've hard-coded your key management into the proprietary systems provided by those public clouds, it can get quite difficult. It's a technical silo. Additionally, with DevOps, there's several risk factors. It's not just a singular web server. Every container might have its own mutual TLS authenticated session requiring a certificate. Therefore, you have an enormous proliferation of certificates. And again, differently than what you might have with SSL, you're not having just 1 year or 2 year, 3 year lifespans of those certificates. The lifespan of certificates in DevOps can be very short. So therefore, you could probably map all of these transformational use cases to several risk factors. Now, what you'll quite often see in technical journalism is the criminal activity aspect to this. In other words, if you get any of these risk factors wrong, and you're not handling these transformational use cases well, you're obviously opening yourself up to criminal activity. But I think one of the things that is maybe even more important has to do with just pure business performance. Imagine those DevOps certificates, as an example, having been issued incorrectly, or having been the CA is installed in a location where it's the uptime level of that computer is not very good. You could have enormous risks to performance and outages. You could open yourself up to all kinds of risks that way. You might have an older PKI for authentication purposes that comes under all sorts of governance within your industry. Well, what happens now with your DevOps or your IoT PKI? You might be subject to compliance failure there. These are all problems that I think innovative techniques and technologies that have now come into PKI that Lindsay and I will be talking about today. This is really what we're trying to address. Let's take a moment to give an example. I'll highlight specifically in 2018 when a single certificate that had expired, I believe it was Ericsson who was hosting that. It was the O2 and SoftBank specifically had most of their customers had an outage for a fairly lengthy period of time. And if I'm not mistaken, the number was around 150 million pounds of damage. That number could even be higher. But those are the kinds of numbers that we're talking about in terms of levels of risk, just of a single certificate being not misissued, but a single certificate being mismanaged. The days of managing certificates within a spreadsheet and then renewing them in a manual fashion is extremely problematic and leads to these enormous certificate failures.
Yeah, and Jay, if I may, the 2017 Equifax breach was made possible because a data monitoring system failed, and that system failed because of an expired certificate. And that made it possible for the criminals to sit there and harvest data for around 75 days before they were detected, when otherwise they would have been stopped right away. And of course, if you want to talk about the economic bottom line on that, Equifax was fined $700 million. So that was a $700 million error by allowing an expired certificate in a critical system to not go addressed.
So Tim, I think there's several conclusions we can take from this, but regardless of the size of your enterprise, there are things to worry about with respect to the management of identity-based security. Like I said before, what used to sometimes be quite a manual effort really needs to have a more innovative, automated approach so that we can avoid these extremely costly outages and basically opening up the door quite often to malicious intent as well. So in the world of IoT, either static credentials or credentials that have actually been issued in such a way that they're not protected very well, this is something, or managed very well, this is something that we're now seeing not just in enterprise computing systems and IT systems. We're also seeing these kinds of problems now creep up into operational technology systems, things that actually, where the rubber hits the road quite literally. What each of these use cases that you see an image of on the screen have in common is that Sectego is actually involved in innovating PKI in each of them, whether that's consortiums that are responsible for the identity-based security behind electric car charging points or electrical grid generation, or of course airplanes, tarmacs across the world, broadband communication of all the different devices that are going on a tarmac, or very importantly, medical devices. Each of these use cases you see here, the risks go far beyond fraud. We're now talking about risk to human life, just risk to individual downtime, but from a corporate standpoint, enormous risks to brand. Thankfully, the consortia behind each of these use cases have chosen PKI as the basis of their security mechanism. And Sectego is involved in each of them. How has PKI risen to the challenge? This is what I think we're going to spend most of the rest of this deck about. And then Lindsay is really going to drive home the ideas that I'm just going to introduce here. Why PKI? And I think it's good just to pause again and understand why we're talking about this technology with respect to some of these use cases where you might not have thought PKI was in there. So let's step back and ask, why PKI at the center of each of these consortia, at the center of a lot of what you're doing in your enterprises with respect to identity-based security. Perhaps far more ubiquitous as a technology than you might realize. Every time that you actually download a song from one of the streaming services, from one of the major smartphone companies, PKI is the basis of securing that. Additionally, every time you use your credit card, PKI is actually behind that as well. PKI is actually at the center of all kinds of infrastructure in the banking industry, finance, as well as all sorts of other use cases that affect you on a daily basis. It's utterly ubiquitous.
Jay, you and I have said in the past, I think it bears saying again here, is if PKI were to magically disappear, our entire digital world would essentially be rendered inoperative. It is that ubiquitous. There is really nothing you're doing with any computing device that you could continue to do if there weren't any PKI in the world.
Yeah, that's absolutely correct, Tim. And I think even some of these transformational use cases where we're going to drill in, where PKI is innovating quite a lot, you'll see that this trend that you just talked about is going to continue. And part of the reason for why it's being chosen at the center of these consortia, at the center of these modern transformational use cases, is because of the fact that it is proven and reliable. And ultimately, it's because it's very, very secure. And part of what we're trying to add in is that capability of it being versatile into these newer technologies and newer use cases that we should start talking about now. The problem is, if you remember, those of you who've used PKI in the past, PKI can be quite difficult to implement. And one of the big problems, of course, is the speed of time it takes to actually implement a full PKI and the costs associated with that. Well, nobody in IoT and nobody in DevOps wants to have very difficult PKI implementations. So therefore, we spent a lot of time automating away a lot of what it used to cause it to be slow to implement. Think about the price, even just the price point of an SSL certificate versus the price point of an IoT certificate. Obviously, PKI has had to innovate to be able to get the price points to the correct levels to match so that PKI could be a useful technology from a cost standpoint for those transformational use cases. I'd like to say with my team, one of the reasons why we've been able to have that versatility of PKI is because we've taken the underlying technology, the technology that, as Tim said, is completely ubiquitous across computing systems, and then made it purpose-built for IoT, purpose-built for DevOps, purpose-built for things even such as SMIME certificate management. Part of it, of course, is usability. One of the design philosophies that Sectego has as part of the IoT PKI offering is understanding that the people who might be operating the PKI might be not 20-year grizzled veterans of the industry. You might have people who are wearing hard hats who have a very important day job that's not necessarily dealing with the intricacies of PKI. Therefore, making it usable is incredibly important. Obviously, as we said earlier, also making it economical. The price point of not just certificate issuance, but the entire platform needs to be set correctly. Scalability. We're not just talking about thousands of authenticated human users. We're now talking about millions of IoT devices, millions of DevOps containers out in the world today. PKI has had to scale in ways that it's never had to before. And as well, agility. Tim Callan and I have in the past talked quite a lot about the post-quantum world as an example. The cryptographic algorithms that we will be using in PKI today may not be the ones you use in 5, 10, 15 years. Therefore, systems have had to be made to be agile. So for each of the PKI systems that Lindsay's going to be talking about later, each one of them is really about a purpose-built PKI that addresses these concerns. What are the qualities of the new PKI? Well, let's first start talking about what the old requirements that still matter. What always mattered was high uptime, the ability to interoperate, and the ability to be measured for governance purposes. Those things have never changed, and perhaps they're even more important than ever. I'd like to say that the new requirements are what we touched on in the previous slide. Scalability, cryptographic agility, but also, as we said at the very top of this presentation, it's all about automation. This slide is an important one in the sense that What we're really trying to show is that in a modern enterprise, the various use cases where PKI is being used is vast. Employees that are using VPN technologies, people who are using SSH authentication technologies in order to be able to remotely administrate cloud resources. Document signing as well, something that you might also be doing in your enterprise. Mobile devices, provisioning of networking gear, even IoT and DevOps, all of the different identity-based security systems that sit behind each of these use cases in your enterprise. As a CISO, as a CIO, if I'm a risk officer, I look at all of these use cases and realize I actually need to manage the certificates and make sure that the certificate issuance is correct, as well as all of the different things such as certificate expiry, the certificate profiling. Each one of these use cases needs to be unique. In the past, where you might have locked down the PKI behind perhaps your VPN system and even your mobile devices, for as an example. Problem is, these new use cases such as DevOps and IoT and SMIME, which was always difficult, problem with those use cases is the PKI behind those systems, you might not have visibility. Governance becomes an incredible challenge. What we're trying to show here, and what Lindsay will be talking about in his slide deck, specifically with respect to this slide and the ideas behind it, are how you create a single pane of glass for your identity-based security within your entire enterprise, right across all of these use cases. So let's address these use cases very directly. And once again, what are the transformational use cases that we'll be talking about? Our mobile devices, DevOps, multi-cloud IoT, and of course, authenticated email. Email, of course, email's been around a very, very long time. But I think one of the reasons why we are revisiting it is because there are problems with it. The FBI, of course, has taught not that long ago the scale of attacks, business email compromise, and spear phishing are enormous, and the growth rate of attacks seems to be doubling on either a yearly basis or even more. But it's not just BEC, or business email compromise and fraud. It's also the stealing of intellectual property. Basically, what happens if in your enterprise you lost your emails? Well, to Sony, the result of that was millions or even more dollars worth of damage in terms of loss of intellectual property, as well as all kinds of embarrassment, which is now still out on the internet to this day. The Democratic National Party has had a large chunk of its emails be made public. Not something that I'm sure they intended or ever had wanted, but it had a large political impact.
Yeah, and if you want to talk about impacts on these things, Jason, the Sony breach ultimately cost the CEO of Sony her job. As the CEO, you can lose your job because you're not pursuing this kind of security correctly. And the DNC breach arguably cost the Democratic Party the presidency. So, the stakes are very, very high on these.
The problems with email, which is a protocol that we've been using now for decades and decades, right from the beginning of the internet, just seems to continue. One of the solutions that had been proposed years ago, which are SMIME keys. I'll just bring up one simple problem with this, which is when I talk to customers about SMIME, one of the issues they bring up is, well, if I lose my key, which is something that could happen just by a hard drive of a computer just dying, how do I retrieve my emails? I will essentially be denied my own emails. It's great that the bad guys don't have them, or aren't able to crack them, but I won't be able to see them either. Therefore, there's innovation needed to break this cycle of insecure email. All right, so let's talk about SMIME and what's required. Obviously, Lindsay's going to go into the roadmap of what Sectego is doing with this, but most of you out there who might know Sectego know that we are a big issuer of SMIME certificates, but we go beyond that. So let's dig further into SMIME. One of the things that we've added a lot of innovation to are a few areas that I'd like to highlight before Lindsay touches it much further. One of those things happens to be the secure email gateway. One of the problems with SMIME certificates that I know that I've talked to customers about is, how do I search my encrypted emails? And one of the things that, of course, with when you're just using SMIME certificates themselves, is an encrypted email can be quite difficult to search. But a secure email gateway takes advantage of the encryption key escrow service, which then allows a gateway to do a search mechanism on encrypted emails on your behalf. It's doing this in a very secure manner, and then gets rid of that main adoption point issue that plagues SMIME. Thankfully, we've innovated to solve that problem. Again, the encryption key escrow service which is important for that secure email gateway, is also used to solve the problem where you might lose your SMIME certificate. If you need to re-provision a directory service or a mobile device or a laptop or a desktop computer where you happen to be using a copy of that SMIME certificate, those certificates are kept in a safe place, and whenever they're re-needed, either for the gateway service or re-provisioning, or even if you lose them, that secure place is now part of the automated SMIME management system that Sectego has. And one of the systems that I'd like to highlight always when I talk about innovation in PKI, innovation within SMIME specifically, has to do with new technologies in mobile devices. The operating systems behind Apple's iPhone as well as Android devices are now including MDM or mobile device management like technologies that we've actually embraced and taken advantage of to be able to have what we like to call a zero-touch provisioning. What used to be quite difficult in terms of provisioning users into your enterprise with SMIME certificates is now been made far more easy. That's something that, again, Lindsay will be touching on a little more in his roadmap. Let's go a little bit further in mobile devices and talk about how things have changed. I know that in the past, really wasn't that long ago, where much of what we did in an enterprise environment was dominated by a Microsoft stack of technologies. Let's take a look just at one particular set of technologies with mobile devices. Where does Microsoft stack of technologies sit within that? This slide suggests that it's less than 1/3%, but I would say that this is probably even less than that. And so therefore, PKI really needs to go beyond what was part of just the Microsoft tech stack of technologies, the Microsoft CA, which many of you are familiar with, and realize that you either have to go with an entirely new PKI that can actually deal with these operating systems beyond the Microsoft stack, or you need to augment your Microsoft stack in order to be able to deal with these other operating systems. And that's something else that, as Sectego, part of our design philosophy is to be able to deal with these new operating systems and new platforms that you'll be facing in your modern enterprise. So to push that analogy further, it's really all about trying to get those identities into all the different places where you need them. So whether you're wrapping your Microsoft CA proxy so that you can actually get certificates out into your networking equipment or your laptops, as you might have for a very long time, but also REST APIs in order to be able to have a very custom programmatic experience to provision certificates into applications or any other place where you happen to need them. One of the other things you'll see Sectego doing is embrace non-proprietary or open standards of provisioning technology. Many of you who in the mobile operating systems know about SCEP, but for other technologies such as IoT, we're now seeing provisioning standards such as Enrollment over Secure Transport or EST, but we also embrace proprietary EMM or MDM standards as well to provision your mobile devices. Certificates are going everywhere, and the ability to provision into each of these types of technology within your modern enterprise is very important. So therefore, part of the innovation has been not just the automation of certificate issuance, but the provisioning technologies that are important to get those certificates from the issuing platform to the destination that you need them. And I just want to pause and talk about DevOps as a transformational use case for a moment. The reason why we have DevOps, the reason why this new culture has been embraced by the modern enterprise is because of the fact that development teams and operation teams need to be able to work much more closely together in order to be able to put out product, in order to be able to build new systems. What used to be large monolithic ERP systems, as an example, are now being broken down into their constituent components, and that has required an entirely new set of technologies. And in fact, the entire set of technologies behind DevOps, I think where it's important with PKI, and to bring out the importance of this, especially for governance and risk officers who might not fully appreciate what's going on in the DevOps culture today, has to do with the fact that PKI is at the center of issuing identities to microservices, container systems, container orchestration systems. So each of these technologies actually has certificates as the basis of how these things operate across network boundaries. Obviously, we're talking about something that's introducing a lot of risk, whether it's breaches or non-compliance, things like outages that Tim was talking about earlier, these are even perhaps more important now with your modern web applications that are DevOps based. In terms of PKI, the risk factors that we're dealing with here are the sheer volume of certificates. What used to be somewhat difficult to manage manually in the days of just doing web server management for SSL as an example, think of each container being its own web server as an analogy. The volume of certificates in containers versus the number of web servers you have is more than 10 to 1, perhaps 100 to 1. The lifespan of those certificates is now getting shorter and shorter. Certificate lifespans can be as short as a minute, a few seconds, perhaps even less than a second. But keep in mind that your certificate orchestration engines are typically something that are within the hands of your operations and development staff. And therefore, the CAs or the certificate authorities that they're going to be running might be running in areas that are not in the same places where you're running your main human authentication PKI systems. And therefore, it's a decentralization of control. Are the certificates being issued into those certificates have a reasonable certificate policy? You don't know these things unless you can regain control. And let's not forget the fact that DevOps systems to this day are very, very complex. And therefore, that decentralization of control is amplified by the fact that you're now dealing with dozens and dozens of semi-related technologies that actually deliver your new modern enterprise DevOps applications. So how do we deal with that? Well, once again, on the left-hand side, Sectego's really, our core strength has always been about certificate issuance. But we've now pushed it farther than that. We've pushed it, of course, into automating the day in the life of a DevOps operator. That person, because they're probably building or maintaining a web application, is probably dealing with web servers and load balancers in their daily life, and therefore needing to have visibility to SSL certificate management. That same operator might also be needing to remotely administrate cloud resources with SSH. And then on top of that, the actual secure containers that are being issued by those people, they need code signing. And so therefore, the integrity of the code that's actually being implemented into your orchestration engines, just like you always needed code signing for code that you might issue in traditional enterprises. It's the same thing with DevOps, except that these containers are ephemeral, needing to be swapped out quite often, sometimes. And then in each of those cases, the integrity of that code needs to be protected, especially because of the fact that these systems might be in public clouds or in hybrid clouds, perhaps in areas that are not completely under control of your enterprise. It really highlights the importance of locking down those containers. And each of these containers in themselves needing to be provisioned with TLS certificates. If you're a DevOps operator, you might also be dealing with the issue of today you might be provisioned all of your loads on Azure, as an example of a public cloud. But tomorrow, your CISO or somebody else, perhaps your CIO, might say, you know what, I got a better rate with Amazon AWS. Why don't we swap over our loads to that service? Well, part of the problem with that is if you as a DevOps operator have actually hard-coded your services within the key management services of those public clouds, you might actually be locked in. Keep in mind that there are PKI trust models that can extend beyond just singular public clouds or any other type of cloud. Therefore, Sectego as a public CA can do certificate issuance in a trust model that extends trust across public clouds, private clouds, hybrid clouds, or perhaps even your partner's cloud. This is an important concept within PKI, the ability to have a hierarchy of trust that can extend across each of the systems will enable you to not just avoid getting locked in by a particular public cloud vendor, but also extend to you a more versatile modern enterprise, being able to extend trust across your different types of compute platforms as well as to third parties. And we're going to end with the idea of IoT, where PKI has had to evolve in order to be able to address the problem of IoT security. How did we end up in the situation we are with IoT security? The computer that you probably logged into today, probably you might have used a username and password, essentially a static credential. We know, of course, that static credentials or username and passwords have been problematic. What was one of the ways that we tried to solve that in a modern enterprise? Multifactor authentication was an example. problem with an IoT device is if you've hard-coded a username and password, you can't hand that IoT device a multi-factor authentication device and then be told, hey, just click the confirm button or get a one-time password in order to be able to authenticate yourself. An IoT device is not going to be able to utilize this. In the recent past, we've also seen that the management of digital identities within IoT has been very, very difficult. Using traditional technologies such as Active Directory or various other types of LDAP technologies has failed because of the scale needs of IoT. IoT devices, of course, are dealing with a scale that Active Directory and LDAP were never meant to deal with. And all of this really came to a fine point not that long ago when we saw a use case example such as closed-circuit televisions being provisioned with hard-coded username and passwords that were unable to be changed, which were then the basis of the Mirai botnet. The Mirai botnet code takes advantage of those static credentials within IoT devices and can mass harvest them for malicious purposes. It's almost certain that the people who manufactured those closed-circuit televisions probably never thought of themselves as a target for botnet purposes, which might be used for things such as denial of service against web resources. People who make those closed-circuit televisions might never have considered themselves as potential victims of that or their clients as victims of that. But the fact of the matter is, we've now been taught this by the people who were actually the originators of the Mirai botnet, of which there are variants still spreading to this day. The scary part about all of this is that all the various kinds of operational technology use cases that we've talked about a little earlier in this deck all have a problem of still using static credentials. Thankfully, what has changed in each of these use cases that you see in image 4 here is that the consortium behind each of them have chosen PKI as a way out of this problem. And I think one of the things I really do need to address is legislation that has now arrived. So as of January 1st, 2020, California law has been in place, which has basically addressed the Mirai botnet very directly and has basically, in a nutshell, said that devices need to comply with this concept of getting rid of static credentials, especially credentials which could never have been changed. There needs to be a mechanism to at least change those static credentials from one value to another within its life cycle. And even though that's not a complete solution for PKI, it's now forcing vendors to actually address this problem. Unfortunately, the speed at which vendors were trying to address this problem was slow enough that government did have to intervene. Now, moving further is a proposed federal legislation, which is now actually addressing the problem even further, saying that identity management, or essentially what is PKI, needs to be implemented in IoT devices. And so therefore, if you want to be compliant with future laws, especially even at the federal level, addressing these problems with modern identity solutions such as PKI is one way to keep yourself compliant. And one of the guidance documents that the federal legislation is actually pointing to directly is the NIST Guidance from July of 2019, which says that not only do you have to protect the data security, but also the device security as well. These are the highest level risk mitigation goals that the NIST Guidance actually is proposing. So how do you actually do that? Well, you also need to protect the firmware of the device, you need to protect the data in transit, and you need to protect the data at rest. None of what is in the California legislation addresses this directly, but the U.S. federal legislation does. And so therefore, the future legislation goes much, much further. Problem with the California legislation is the fact that it does not address things such as data in transit, as an example. The problem is, even if you do have a mechanism that can change a static credential from one value to another, and therefore make you compliant with California law, the problem is that that credential might be sent in the clear and not protected as part of data in transit. Therefore, the bad guy who is actually watching the wire potentially can then steal that credential, and then we're back into the Mirai botnet scenario once again. Therefore, that is why that high-level risk mitigation that is actually been proposed by NIST as part of their guidance talks about this integrity of the device itself. So once again, you know Sectego as an issuer of digital identities. Part of what we also enable is the provisioning of IoT devices, which can be quite complex. We do this in several ways, not the least of which is programmatically through REST APIs, but also by embracing open standards such as Enrollment over Secure Transport Protocol, or EST. And further to that, we also offer technologies that help you to be compliant to NIST guidance. technologies such as TPM integration, which is the ability to take that provision certificate and put it into a hardened secure element to protect that private key material, protection of secure boot, and also technologies to be able to monitor specific industrial or operational technology protocols. We offer those technologies ultimately so that within the operational lifespan of the device, all the data going back and forth between these IoT devices and their gateways or the cloud or other devices can actually be protected. Certificate renewal, which is something that in early IoT devices was difficult or possible, those are technologies that we're now bringing to bear. So with this slide, I really try to offer that Sectego is a trusted third-party CA, an expert at PKI issuance at high scale, high agility, and usability. It is also bringing supplementary technologies to be able to have a full stack of IoT security. So where does Sectego play in public realm? And one of the areas that I deal with on almost a daily basis is dealing with standards of technology with respect to identity-based security within all these different consortium. So Sectego is actually the sole root of PKI behind the SunSpec Alliance, as well as co-root in the Open Connectivity Foundation, and also the WiMAX Forum AeroMax consortia as well. So those are ways in which Sectego has innovated and has participated in modern PKI.